Hey guys, in this video we are going to talk about how to divide when we have radicals involved. And in order to do this, we're going to start off with a property. It's called the quotient property of square roots. And this property says, this is an a up here, if you have the square root of a fraction, a divided by b, then you can break it up and do the square root of the numerator over the square root of the denominator. So again, if you have a fraction, like let's say you have the square root of 2/3 we'll go with, that would be the same as the square root of 2 over the square root of 3. And you also can go backwards, like maybe you have the square root of, let's do 12 over the square root of 6. You can go backwards the other way. This would be equal to the square root of 12 over 6, which then you could even simplify and say is the square root of 2. So this has uses going in both directions, and we'll see both those directions. So you can use it to simplify, it'll make simplifying easier, and we'll see what happens when we go this way. So up until now, we have talked about being in simplest form. And being in simplest form, so far all we've said was everything underneath the radical needs to have all the perfect squares factored out. Like the square root of 8 is not in simplest form, because the perfect square 4 is in there. So it'd be square root of 4 times 2, which would simplify this to 2 root 2. This would be simplest form. So that's one of the key properties of being in simplest radical form. We're going to have two new rules that we have to apply as well. So one of them is there can be no fractions underneath the radical. So we can't have the square root of 2/3. This is not in simplest form. We can't have a fraction underneath the radical. And also, if we try to use that property that we just had, maybe you're thinking that property will help us. It will, but it's not going to quite get us into simplest form, because the second rule we're going to have is we can't have any radicals appear in the denominator. This, having a square root of a non-perfect square, we call that that is an irrational number, and we don't want to have any irrational numbers in the denominator. So if this was like the square root of 2 over the square root of 4, you could simply just make it like this, and then you're in simplest form. So we need to find a way to make the denominator not have a radical. And there is a strategy we use for this. It is called rationalizing the denominator. And to rationalize the denominator, what you're going to do is you're going to look at your denominator, see what you have. We have a square root of 3 right now. So in order to get this root to go away, we're going to multiply by the square root of 3 over the square root of 3. And the reason why we can do this without changing the value of this at all is the square root of 3, over here on a little side note, square root of 3 divided by the square root of 3, well, anything divided by itself except for 0 is 1. So we're essentially just multiplying by 1. And if you multiply any number by 1, you're not changing its value. That's the multiplicative identity. You're still equal to yourself. So we're multiplying by 1, but it just looks a lot different. It doesn't look like 1, but it has the value of 1. And the reason why we do this, well, just like you would multiply fractions in the past, you multiply the numerator. So you would have square root of 2 times the square root of 3. You multiply your denominators. Now on top, you can't really do anything. You're going to end up with the square root of 6. You can still use that multiplication of square roots property that we know. But on the bottom, the square root of 3 times the square root of 3, a couple ways to think about it. You could think of it like it's going to become the square root of 9, or you're going to be squaring the square root of 3. Either way, you should end up with this being 3 down here. And now if you look, denominator has no radicals. There's no fraction underneath the radical up here. This would be in simplest form, root 6 over 3. This process is called rationalizing the denominator. And that's what we're going to spend our time on today. So we'll do some examples with these to see different ways we can use this. So our first example, we have the square root of 10 divided by the square root of 3. So now we are already broken up into numerator and denominator, have their own roots. And to rationalize the denominator here, because then we can be in simplest form, again, we're going to use the square root of 3. We're going to multiply the top and the bottom by the square root of 3. So on the bottom, you'll be left with 3. On the top, you're going to have square root of 30, 10 times 3, underneath the radicals. We can't simplify this at all, so we're going to go ahead and leave it like this. This would be simplest form. All right, our next one, we have the square root of 3/8. So first off, we need to get the fraction out of the radical. So we'll have the square root of 3 over the square root of 8. Now there's a couple things you can do here. I'm going to go ahead and simplify first. I prefer to simplify first. So we'll have square root of 3 over, down here you could simplify and you'll end up with 2 root 2. And then I'm going to go ahead and multiply the top and the bottom by root 2. So on the top, you're going to have square root of 3 times the square root of 2 is the square root of 6. On the bottom, you're going to have 2 times the square root of 2 times the square root of 2 is 2 times 2 on the bottom you'll end up with. So you'll have the square root of 6 over 4. This would be in simplest form. If you didn't want to go this route of simplifying first, you don't have to. You could do, I'll write it over here, you could just multiply the top and bottom both by the square root of 8. So you could do it like this. Then on the bottom, you'll end up with an 8. On the top, you'll end up with the square root of 24. You can simplify the square root of 24 though, and that would be, let's write it over here, you would end up with the square root of 6, and you would factor out the square root of 4, which is 2. And then in this part, you'd have to simplify. You have a 2 and the 8 here, so you would end up with, a 4 on the bottom. This would be like having 2/8. Think of like the radical as like an x, like a variable. 2/8 is like your coefficient. You could simplify that to 1/4. Either way, you end up with root 6 over 4. We're going to try a couple more, then I'll give you 3 to try on your own. So our next one, we have 4 divided by square root of 6. So we need to get that radical out of the denominator. So we're going to rationalize the denominator by multiplying the top and bottom by the square root of 6. So then you're left on the bottom with just a 6, and on the top you're going to have 4 times the square root of 6. And we got all of the radicals up top, but we do need to simplify this. You have the 4 divided by 6, which would simplify to 2/3, and we still have the radical 6 here. So 2 root 6 over 3 is our simplest form for this one. All right, our next one, there's a few ways we can do this one, so I'll go through both of them. Okay, so let's say you want to rationalize here. You see the square root in the bottom, you want to get that out, and you multiply by root 3 over root 3. On the bottom, you'll be left with, 3. And on the top, you would have 12 times 3 to have the square root of 36, which will get you to, well, that's just 6 over 3. This one actually simplifies to have the same value as 2, this expression here. That's one way you could do it, and that's perfectly fine. Another way, a little sidebar, and if you saw this, great. If you didn't, that's perfectly fine too. As you have more practice, you'll start to recognize things. Remember that property we have? We can go backwards with it. So the square root of 12 over the square root of 3, that's the same as the square root of 12 over 3. The only reason I would use that here is because I know this is going to simplify to a nice number. Square root of 12 divided by 3 is 4. Square root of 4 is 2. So you get to 2 anyway. Either path is fine. You just want to get to the correct final value. So the square root of 12 divided by the square root of 3 has the same value as 2. Alright, let's go ahead. There's 3 of them if you want to try them on your own. If you want to go ahead and pause and give them a try, then I will do them on here, and you can check and see if you got the right answers. So our first one, we have the square root of 3 over the square root of 10. You're going to need to rationalize here. So I'm going to multiply the top and the bottom by the square root of 10. You'll be left with a 10 on the bottom and a square root of 30 on the top. Can't simplify that radical, so we are in simplest radical form right here. Our next one, we have square root of 20 over the square root of 4. With this one, again, I would recognize we could go backwards with it. Square root of 20 over 4 would be the square root of 5, and you can't simplify that. So you're all done. If you didn't like that method, I'll go down here in green. Maybe you did it this way. You can, actually there's 3 ways you could really do this. You could try to rationalize if you want. You'll end up with 4 on the bottom. Then you're going to have square root of 80 up here. But you might notice, and I'm going to go back to this, 4 times 20, you're going to end up with, actually let's go back to the 80. 80 is 16 times 5. So you could factor out that square root of 4, and you'll end up with just the square root of 5. Another way you could actually do this one, and I'll show you a third way for it, because maybe you saw this first, and this is fine too. Square root of 20, maybe you just know the square root of 4 is 2, I think we all know that. So you can just write a 2 down here, and then you're almost in simplest form, but you do need to simplify this radical up here then, in which case you would have square root of 4 times 5 up here in the numerator, and then you would get out your square root of 4, which would be 2 root 5 over 2. And your 2's cancel out, so you just have root 5 that way as well. All different ways to get to the same value of root 5 in the end. You even could, at this point, maybe you left it like this. Instead of having the 2 on the bottom, maybe you left the square root of 4, and the square root of 4 would cancel out there as well, and you still get that root 5. A lot of different ways to get to the same answer. It's good to know different paths as well, because sometimes others are more useful. And our last one, though, of the day, we have 14 over the square root of 32. So if you want to simplify first, you can. If you wanted to rationalize first, you can. I'm going to simplify. So we end up with 14 and 32. I know 16 goes into that. So 16 times 2, the 16 will come out and become a 4. So you'll end up with 4 root 2 in the denominator. And then you just need to simplify. So 14 and 4 both have a 2 in common. So we have this. Let's get that radical out of the denominator, all multiplied by root 2. So up top, you have 7 root 2. On the bottom, you'll have 2 times root 2, which is going to end up being 4 in the end. And there you go. If you tried to rationalize first, I think that one was a bit more of a pain, because you would have to deal with multiplying by the 32. That's why I like to simplify first. It makes things a little bit easier some of the time. Alright, so that's all you have for today. Go ahead and practice. This is called rationalizing the denominator, and personally I think it's really fun. So have a nice day, guys.